How to identify polymer types. Have you ever wondered how to tell different types of polymers apart? Understanding polymer types is key to figuring out how materials behave, diagnosing product failures, and preventing mechanical breakdowns. Let's break down the steps to identify polymer types, starting with some basic methods. First up is visual inspection. Look closely at the polymer's color, transparency, and form. For instance, a clear, rigid polymer will look very different from an opaque, flexible one. This initial observation can help narrow down the options quickly. Next, we have density testing. Polymers have specific densities that can be tested by immersing a sample in liquids with known densities. If the polymer floats, it has a lower density than the liquid. If it sinks, it has a higher density. This simple test can provide valuable clues about the polymer type. Solubility testing is another useful method. Different polymers dissolve in certain solvents. By testing a polymer in solvents like water, acetone, or toluene, you can create a solubility profile. This profile can then be matched to known polymers, helping to identify the material. Another interesting test is the burning test. Observing how a polymer burns can give you hints about its identity. For example, polystyrene burns with a sooty flame and a distinctive styrene smell, while polyethylene burns cleanly with a paraffin-like odor. Always conduct this test in a well-ventilated area for safety. Once you have done these initial tests, you can move on to more advanced techniques for definitive identification. One powerful method is Fourier transform infrared spectroscopy. This technique measures how the polymer absorbs infrared light, helping to identify chemical bonds and functional groups. It can confirm the polymer type and even detect any degradation. Differential scanning calorimetry is another advanced method. It assesses thermal properties like melting temperature and glass transition temperature. This information reveals the polymer's crystallinity and thermal stability, which are important for understanding how it will perform under stress. Thermogravimetric analysis measures weight changes as the polymer is heated. This data can provide insights into thermal decomposition and filler content, which relate to the material's durability. Raman spectroscopy is also useful for gathering molecular structural information. It complements Fourier transform infrared spectroscopy and helps in polymer identification. X-ray photoelectron spectroscopy analyzes surface chemistry, detecting elemental composition and chemical states. This is important for understanding surface degradation or contamination that can lead to product failure. Lastly, pyrolysis gas chromatography mass spectrometry breaks down polymers thermally and analyzes the fragments. This method offers detailed compositional information, especially for complex or unknown polymers. By combining these techniques, you can get a complete picture of a polymer's characteristics. This knowledge is essential for diagnosing product failures. It helps determine if the right material was used, if degradation processes contributed to failure, or if additives affected performance. Identifying polymer types is a step-by-step process that starts with simple observations and moves to advanced analytical techniques. Each method provides important information that helps understand material failures and mechanical breakdowns in everyday applications.